Welcome to Bravel Institute of Actuarial Studies. Today we are discussing about two-state Markov model. So Markov model itself, they explained that they are considering only two states. What are the states? First state is alive state. First state is alive and second state is dead. So he is considering only two states. First state is alive and the second state is dead. So he has explained that there is a transition is happened from alive to dead. It's a transition from alive to dead. This is called transition intensity or transition rates or force of transition. So there is alive to dead, there is a transition rate is calculated mu of x. For example, at the age of this mu of x is depend on the age. So at the age of 49 to 50, at the age of 49 he was in the alive state, but at the age of 50 he moved to dead state. So this transition rates may be 0.01. This is on, we can say 0.0001. But in the age of 30, 32, at the age of 31, transition is happened from, he was in 30, at the age of 30 he is in alive state, at the age of 31 he moved to dead state. This intensity may be 0.001. Intensity is reduced because age is come down, intensity is reduced. But in the age of 80, he reached at the age of 81 is moved to dead state. This may be intensity will be high. Intensity will be high because age is increased. At the above 60 age, intensity will increase. So a transition, there is a transition probability. Then we consider transition probability. We are in the age of, we are in the state of alive and move to dead state. What is the transition probability? From moving alive to dead. This we can say T of Q of X. We can explain that T of Q of X. This is a transition probability. At the age of X, this is the age of X. At the age of X, we are in the alive state. At the age of this is a time will be T. This time will be T. At the age of S plus T, we moved to dead state. So this is a probability of person at the dead state, at the age S plus T. At the age of S plus T, he moved to dead state. Given that alive at the age X. So this is the explanation. TQ of X. What is the TQ of X? Probability that person at the age of S plus T is moved to dead state. At the age of S plus T, he is in dead state. But at the age of X, he is in alive state. At the age of X, he is in alive state. So this is a TQ of S. This we can call transition probability. Another one is TP of X. TP of X. What is a TP of X? Sometimes person at the age of X, he is in alive state, but he is continuing the same state. So person probability that we can call survival probability. At the age of X, we are in the alive state. At the age of S plus T, we not moved to dead state. We are continuing the alive state. So we can say person at alive at the alive state at the age of S plus T. At the age of S plus T. Given that alive age X. So this is it to notification T. P of X is called probability that person alive state at the age of S plus T. Given that person alive at the age of X. So this is the probability of T P of S. This is the T Q of S. This is explanation. This one will use widely in all our equations. In this chapter, we required this T q of x and Tp of x, most important in this chapter. In the Markov model and survival probabilities, these two denominations is very much important. Next, Markov model. In this Markov model, he has explained three assumptions. So he's explained three assumptions. First assumption one. First assumption: person in the state of alive at the and next subsequent age. Person is staying at the alive state to moving to any subsequent age depend only in the current state. So we are at the age of 49 and we moved to at the age of 50. So we are at the age of 49, we moved to at the age of 50, moved to dead state. So person is any transition happened from this age to this age. This depend only on the current state. What is this current state? Current state is alive state. This is the current state. This one is only depend the next transition. So he's explained about any event in the past. Any event in the past do not affect any future event. So any events before that, this a person at the age of 49, before that any event is happened, this do not affect the future event. That means future event, this is a future event 49 to 50, this is a transition. This future event not depend on the any past events. So past events we are forgetting about all past events. So what transition is happened 49 to 50 depend only on the current state. This is the assumption 1. In assumption 2 is talking about probability of dying. Probability of dying qs plus t. Probability of dying is equal to mu s plus t into dt plus one correction terms. This is the second assumption. What is the probability of dying? We are at the stage of, this is the s plus t stage. S plus t. We are alive at the age of s plus t. We are alive at the age of s plus t. Is move to small time interval. Small time interval dt. Small time interval dt. This we can call s plus t. We move to dead state. Dead state. So this time will be s plus t plus dt. So we are at the age of s plus t. We are in the alive state. Is moving to dead state at the small interval of time dt. So this transition probability we can calculate by multiplying these two terms. This is a transition intensity. Transition rate is multiplying to time interval. So we are at the age of s plus t. We are at the state of alive. Is moved to dead state in the small time interval dt. This transition probability equal to transition rates. Mu s plus t is a transition rates from alive to dead. Multiply this transition rate into time interval, small time interval. This is equal to this transition probability. So transition probability equal to transition rates into time interval, small time interval. This we are adding some small correction terms. This is approximately, this one is equal, and we are added some correction terms o dt. This is the second assumption. So second assumption, this formula is very much important for our calculation. This formula is very important. So small time interval, person is moving from alive to dead. Person is moving from alive to dead. So this transition intensity is mu s plus t. Small time interval dt. This transition probability we can calculate to multiplying the transition rates into time interval. So this is the transition probability of dt into q of s plus t. This is the second assumption. In third assumption, we are talking about this mu of s plus t is explained. This mu of s plus t is explained. Mu of s plus t mu of s plus t we can say is equal to constant mu. At the time is we are considering at the time 49 to 50. We considering at the time 49 to 50. It's a small time interval. So this small time interval is equal to 1. That is a 1 year. This t is equal to 1. T is equal to 1. T is equal to 1. Or t is equal to 0 to then 1. This is t is equal to 1. If t is equal to 1, then this transition intensity equal to constant. So at the age of 1 year, we are talking about transition intensity will be constant. This is constant mu. This is a constant mu. So for example, we are at the age of 49, moved to 50. This transition intensity, we can write this mu 49. It is a constant. From 49 to 50, this transition intensity is constant. 49 to 50, we can say it's a constant transition intensity, mu 49. Even 20 to 21 also we can say, 20 to 21 we can say mu 20. This will be constant for age of 20 to 21. If t is equal to 1, then transition intensity is constant for that time interval. This small time interval t is equal to 1, then transition intensity, this mu s plus t is constant. In the small time interval t, if t is equal to 0 to 1, that means 49 to 50. In between, we can say this is a 0, 49 to 50. This small time interval, this transition intensity will be constant. That is a third assumption. So first assumption is talking about Markov model. In two-state Markov model, we're talking about first assumption whenever we are in the alive state and moving to dead state. So at the age of probability of at the probability depending on the current state, what we are in the state, that current state, and moving to whatever moving to next state is depend only on the current state. And second assumption we are talking about dt q of s plus t is equal to transition rates into time interval. Third assumption we explained transition intensity equal to the mu. It's a constant for the time interval will be if 0 to 1, then it will be a constant. So these three assumptions will use for the next calculation of survival probability. Please visit my please subscribe my Braille Institute channel and visit my website www.brailleinstitute.com for further for practicing and problems. Kindly visit the brailleinstitute.com. Thank you.